Transpose of a tensor. Definition. The transpose of a tensor T, denoted by T superscript T, is defined as the tensor that satisfies the following identity for all vectors A and B. A dot TB is equal to B dot T transpose A. Is T transpose classified as a tensor? As explained in the video shown at the top right, to prove that T transpose is a tensor, we should prove the linearity of the transformation T transpose. For this purpose, it is sufficient to show that the following identity is satisfied. T transpose of alpha A plus beta B is equal to alpha T transpose of A plus beta T transpose of B for all alpha, beta, A and B. This equality is equivalent to the following equality. Dot product of vector C to both sides of equation 2 for any arbitrary vector C. Let's start with the left-hand side of equation 3. Left-hand side of equation 3 is equal to C dot T transpose of alpha A plus beta B. Using equation 1, it is equal to alpha A plus beta B dot Tc. It is equal to alpha A dot Tc plus beta B dot Tc using distributive property of dot product. Using equation 1, we can write it as alpha C dot T transpose A plus beta C dot T transpose B, and it is equal to, because alpha and beta are scalars, factoring out vector C results, which is equal to right hand side of equation 3. Therefore, equation 3 is satisfied, thus equation 2 is also satisfied and T transpose is a linear transformation or a tensor. Why definition 1 implies T superscript T is the transpose of T. Suppose that A and B in definition 1 are defined as A equals basis EJ and B equals basis EI. From equation 1, using equations 4 and 5, it is concluded that EJ dot TEI equals EI dot T superscript T EJ. As explained in the video shown at the top right, EJ dot TEI is equal to TJI. EI dot T superscript T EJ is equal to T superscript T IJ. Therefore, using equation 6, it is concluded that TJI is equal to T superscript T IJ, or in matrix notation, in other words, the matrix of T superscript T is exactly the transpose of the matrix T. Transpose of T transpose. Substitute T transpose for T in equation 1. From equation 1, also we can write equation 1 as can be seen, the left-hand side of equation 11 is the same as the right-hand side of equation 12. Therefore, from equations 11 and 12, we can conclude B dot T transpose A is equal to B dot TA. Thus, transpose of T transpose is equal to T. Transpose of sum of two tensors. Using the definition of the transpose of a tensor in equation 1, we can write A dot t plus s transpose b is equal to b dot t plus s a. It is equal to b dot bracket t a plus s a. Using the definition of the sum of tensors explained in the video shown at the top right, it is equal to b dot ta plus b dot sa using the distributive property of dot product. Using equation 1, it is equal to a dot t transpose b plus a dot s transpose b, and it equals a dot bracket t transpose b plus s transpose b by factoring out a. As already proved in equation 2, T transpose and S transpose are tensors. Therefore, using the definition of sum of tensors, we can write it as A dot bracket T transpose plus S transpose B. From equations 14 and 15, it is concluded that A dot bracket T plus S transpose B is equal to A dot bracket T transpose plus S transpose B. Therefore, T plus S transpose is equal to T transpose plus S transpose. In other words, the transpose of the sum of two tensors is equal to the sum of their transposes. Transpose of tensor products. The reverse order law. Using the definition of the transpose of a tensor in equation 1, we can write A dot bracket Ts transpose B equals B dot bracket Tsa equals B dot T bracket SA, using the definition of the products of two tensors as explained in the video shown at the top right. Using equation 1, it is equal to SA dot T transpose B, and it is equal to, using commutative property of dot product. Again, using equation 1, we can write it as A dot S transpose bracket T transpose B, and we can write it as, using the definition of the product of two tensors from equations 18 and 19, it is concluded that Ts transpose is equal to S transpose T transpose. In other words, the transpose of tensor products is equal to the product of transposed tensors in reverse order. In general, we can write the transpose of tensor product as